In this video, we're going to relate graphs to events. So we're going to take graphs and we're going to relate them to real life types of problems. Now this is going to seem easy. This can be difficult for some. So let's just start with a problem. And I want you to see if you can interpret what the graph is. So let's look at a problem. One student walks home and takes the bus to get from school to home each day. The graph below shows the student's commute by relating the time the student spends commuting and the distance he travels. So let me actually draw the graph. Alright, so we have the total distance as the y-axis and the commute home as the x. You'll notice that the arrows do not go left or down, since if we're talking about time or total distance, we aren't going to actually need the negative values. Alright, so let's look at our graph. Here it is. Now we have to relate. Now remember, we're relating the time the student spends versus the total distance that they commute. So the time related to the total distance. So what happens here versus what happens here? What happens here, and so on. Now notice that it starts by taking the bus. You can't just say he slows down, he speeds up. That's not what we're doing. You have to be precise and you have to be accurate. So what could be happening here? Now, this is a commute home, and he takes the bus. So what could this be? Okay, he could be walking. So if you notice, this and this part are the same. So let's write this down. His distance here increases slowly. So what happens at the part where it looks like he stops moving? Now you can't just say he stops, but what could he be stopping for? Well, if he's taking the bus home, he's probably waiting for the bus. Now what happens here? He starts going again, but his walking distance is slow. So what do you think? He's waiting for the bus. What happens here? He gets on the bus. Now, you know it's increasing, but you notice that this is much faster than him walking. So then what happens here? He gets off the bus, and he's walking again, and his distance increases slowly at the same pace as what he did when he was walking to the bus stop. So that would be an example how we can describe what this graph shows. In example 2, I want you to copy this down, and I want you to make note that this is a graph that shows a trip from home to school and back. So this kid is going from home to school and then coming back. The trip involves walking and getting a ride from a neighbor. So what do you think each of these sections means? So pause the video and write it down in each section if you would like. Hopefully, you're realizing that if he's at his house, distance from home. So he starts off at his home, and he's getting farther from home. What is he probably doing here? He's probably walking. Let me actually spell walking correctly. He's probably walking to his neighbor's house or to his friend's house. Now, he's actually increasing at a slower rate or a slower speed. What happens here? He's probably waiting at his friend's house. Waiting at his neighbor's house. Now, they get in the car to school. Now, obviously, you'd probably write increases at a faster pace. So what happens at the top? He's at school. Then, once again, he gets in the car. But now he's going home, because we're talking about distance from home. If we were talking total distance like the last problem, this would actually go even higher. But since he's going back home, the distance is falling. Then, at neighbor's house again, and here, he then walks to his house. Now, to be more precise, you should probably in each of the car sections, put increases at a fast rate and then decreases at a fast rate. Here you could say decreasing at a slower rate because he's walking. Example number 3. A plane is traveling from New York to London. The flight takes off, and when it arrives in London, it has to circle around the airport waiting to land. Sketch a graph of the plane's altitude during the flight. Label each section. So I want you to do this yourself. Just make your own graph. So we first have to title it. So once again, you don't have to have exactly a trip to London, but that's what I put. Now we're comparing altitude versus time. So the first thing we're going to do is, well, let's think. The plane is going to take off. The altitude is going to increase. We get to the increasing, and then all of a sudden, what's happening here? It's just flying. Okay, then we're approaching London. Approaching London, altitude's decreasing, and then we get to the airport, we realize we have to circle around a little bit. So circling around, and then we reach the time we can land, and then the altitude slowly goes back down to the airport. So, what happens here? You're taking off, and you could say, taking off from New York. You could say taking off, and the altitude, this is the best thing you could say, the altitude gradually increases. Then at the top, this would be the flying altitude, or what they call it as the cruising altitude. That's when it's flying. Then we start the descent of the plane. Here, we're circling the runway, or circling, waiting for a runway. Then we land. So these are all the different parts of a graph that we can label in showing change versus time and altitude in this problem. Example number 3. Suppose you pour water into a container at a steady rate. What graph shows the change in the height of the liquid in the container over time? So here's your container, it's like a bowl. You're pouring water in at a steady rate. What graph shows the change in the height of the liquid in the container? A, B, C, or D? Each one we're representing H, which is height, versus T, which is time. Which one of these represents the height of the liquid of the container? Hopefully, you picked A. Now you may think, well, wait a minute, it says steady rate. Why wouldn't it be this? Because notice what happens when you start pouring water in here. The bottom of the bowl is very narrow, so as you pour water in at a steady rate, it's going to fill up quicker, and then as the bowl gets wider, it's going to slow down. So the height of the bowl is going to start off quick, and then it's going to slow down as you pour water in because this gets bigger. So A is the correct answer, once again, because the rate that the water rises will decrease steadily because the container gets wider from the bottom to the top.